Good afternoon, everybody. Nice to see the sunshine out there. At least it is in Bushy. I'm not sure it is elsewhere. People have joined us from across the UK and other places today, so welcome to you all. Just a quick update for me, just for the SAGE members. The SAGE committee met again yesterday just to talk through our plans for going back to the shul, which we will be doing PG on the 5th of October. Marlene is just finalising the newsletter and that'll come out to you, I hope, in the next day or two. For those of you not on email, we will be sending out hard copy. And that's, as I say, just to the SAGE members. Okay, right. I'm really delighted this afternoon to have as our speakers Technion. Technion actually came and spoke to us, Alan, as is, probably 2 years ago now, and talked to us about the work Technion do. And I'm really pleased this afternoon that they're giving us another talk, the medical robotic revolution of Israel. And I'm going to hand over to Tony Bernstein, who's going to do the introductions to the Technion speakers. Tony, over to you.
Thanks, Stuart. So my name is Tony Bernstein, and I am a member of Bushy Shul and a very proud member of Bushy Shul. And I've had the privilege, and it's been an absolute privilege and an honour to have been working with the Technion for the past 20 years. And I think that will come across later on with our speaker, Professor Alon Wolf, and also the two films we're going to show. So for those that know me will know that I've been very, very closely associated with the Technion. And Technion is Israel's leading Nobel Prize winning university. And it's one of the top 10 science and technology universities in the world. Its research in engineering, in computer science, technology, medicine is really changing people's lives throughout the world, not just in Israel, not just in Europe, but here in the UK, very much here in the UK. And every one of us watching this program will have been impacted by Technion somehow, whether it's something in the phone that we use, the computer that we use, or a visit to a hospital, or a drug that we're using, or a piece of robotic equipment that's being used. It will be affecting us, but we'll hear more about that later. And at the same time, I don't think I can stress this too heavily, Israel, the state of Israel, relies upon the Technion, on Technion science for its defense. In fact, when the Technion was created and when it opened its doors in 1924, it was always going to be a sort of trailblazing university that was going to build a country of the future. And that's exactly what it did. And that country of the future, which is Israel, relies upon the Technion for its defense, the safety of its people, and also its future. So let's run a short film about the Technion just to see a little bit more. First film, please.
Before we begin, behind the ideas and hurdles, the trial and error, the striving and the greatness, through ups and downs, there is a vision that never changes, the vision to do good. This is Technion. Where does vision come from? From people like you, enlightened minds, who fill the future with care, guardians of all we share. Doing good by protecting this precious planet, harnessing energy resources to empower tomorrow, and learning from the scientific genius of nature. Doing good by advancing world health through revolutionary scientific insight, medical treatments, and life-saving technology. Doing good by opening all channels of data. Predicting future needs, anticipating the next wave of innovation, and keeping it all safe. Doing good by transferring the power of discovery from laboratory to marketplace, and sharing the culture of creativity across the world. Doing good with the vision to create something from nothing. Releasing the power of inspiration so that everything becomes possible. Doing good with Technion, where great minds come together to create a brighter future for all. Technion, from visionary education to a world of impact.
Great. So let's go a little deeper into one aspect of what's going on at the Technion. And this is now about robotics. And I'm delighted to introduce and welcome this afternoon a very great friend of mine, Professor Alon Wolf, who is the Vice President for External Affairs and Resource Development at the Technion. As a bit of background, Alon received his graduate, his master's and his doctoral degrees from the Technion, and is a visiting professor at Carnegie Mellon University in the US, as well as a research scientist at the surgical department of the University of Pittsburgh School of Medicine. He is one of the world's leading experts in the robotics field and is internationally known for his development of transformative robotic snakes designed for detecting tunnels for use in natural disasters, as well as in surgical medicine. And in his spare time, Alon heads the Israeli Olympic Sports Research Committee, a Technion collaboration with Israel's Olympic Committee and First Robotics Israel. Alon is the recipient of many academic honors and awards for his excellence in teaching. So, with the subject of the medical robotic revolution, I'm very proud to welcome my great friend and highly respected colleague, Professor Alon Wolf. Over to you, Alon.
Tony, thank you very much. Thank you for your very kind introduction, and I'm very honored to join you this, for me, afternoon, for you, noon, and I'm sorry, I heard the discussion before about, the fact that we're meeting still over Zoom, and I wish I could be there with you physically. There are many advantages of seeing people face to face, but there's also advantage to have everything by Zoom. We could coordinate this to Tuesday, which is twice as good, as God said. And there's another advantage. I think it's your 2 p.m. So if the speaker is too boring, you can always close your camera and take a nap. So with this, I'll just go into my talk. And as Tony mentioned, I'll talk about robotics and some ethical aspects of robotics. I think that what we are experiencing nowadays with the pandemic and climate change and everything, there's a lot of questions raised about technology and whether it's good or whether we benefit or we don't benefit from it. So I'll try and share my screen now so I can you can watch my presentation. I hope you can. Do you see the screen? Tony,
Yeah. The
Good.
14th revolution in robotics. Yeah.
Good. So the I4 revolutions and robotics, some history, philosophy, and ethical issues. Tony mentioned the Technion, and Technion is the first university in this part of the world. It was established in the cornerstone was in 1912, and we opened our gate or our school and our teaching in 1924. Very advanced thinking in establishing this university, but we can talk about this in another time. Just as a side note, on the first class of 1924, there was one woman graduate. And this is not something which was common in 1924 to have a woman getting an engineering and science degree in a university, even in Europe, not just in Palestine. Technion was always in every milestones on the development of the country of Israel, from its establishment, 24 and opening its doors 24 years before the country was actually announced, through the digital revolution, the microelectronics, the electro-optic revolution, medicine, technology, quantum, and so on. It's been always leading the efforts in Israel. So many actually credit the Israeli high tech to things that were developed at the Technion. We also have three campuses, one in Haifa, the main one, the one you see here in the picture, and two other campuses, one in China, in Guangdong, and another one in New York, in Roosevelt Island, collaboration with Cornell University. So we're very global, very international. So if you look at the globe behind me, and you put China, Israel, and America, and New York, you realize that the sun always shines on the Technion. With that, let me talk a bit. Let me go to to the topic I want to discuss today, and it's the digital revolution and robotics. The digital revolution, or as we call it, I4, Industry 4, is here because of many technologies that matured in a single or in a very packed time in space or in human history, let's put it this way. Whether it's cloud computing, maybe you've heard this, the fact that we can do things on a virtual machine or computers that are called clouds, the Wi-Fi that we are connected by internet, Bluetooth, mobile internet, 4G, now we're talking about 5G, you may have heard this, deep learning, artificial intelligence, I'm sure you heard it on the news, on newspapers, and low price sensors, natural language processing and Internet of Things. All these is part of a revolution. They all matured in very, I would say, 10th time in human history. I think that someone is actually hacking into our Zoom and is I don't know if someone can take these sketches off. Do you see the red, Tony? You see the red lines? Yeah. Someone is yeah. This is part of the ethical issues that I would like to discuss. Digital is good, but if we were now face to face, this probably wouldn't have happened. So when we talk about Industry 4, there must be also Industry 1. And the first industrial revolution happened actually in your country, in the United Kingdom, around 1780, with the steam power and the revolution of having a lot of technology or machinery converted from human manpower to a machine that does the work for us. So from the first industrial revolution, as you can see here, steam power, to the second industrial revolution, the autonomous or assembly lines or the assembly lines with Henry Ford and Heinz with the food industry, to the third industrial revolution where we have IT, internet technology, and robotic arms and assembly lines integrated into manufacturing, to the industrial revolution, the fourth one that we're experiencing right now, which is based on cyber physical systems. And when we say cyber physical system, it means that all these devices that you see in the previous industrial revolutions are now connected. They talk to each other, they are connected to each other, and they produce a lot of data. How intensive this revolution is? Well, it's very intensive. Everything becomes smart around us. You're using a smartphone, you have a smart car, you have a smart home, and smart buildings, smart grids. Everything becomes smart because everything is connected and talks to each other, is connected through computers and a lot of technology. So the revolution that we are experiencing, and I'm sure that you are also experiencing, is very, very, very impactful on our life. Actually, yesterday I had this discussion with my father, and he was complaining that he cannot even go to his bank anymore because there's no one there. Everything is done now online, so the bank is open only 1 or maybe 2 days a week because you do most of the things over on the internet. So this is how big the impact of this revolution on our life. And one more thing to notice is that things change, and they change very fast. Actually, they change exponentially. And I'm sure you heard this word also now in the news, referring to the COVID pandemic, how fast it spreads among people, and it spreads exponentially. It means it's not like a line, a linear line. It's a curved line that that means that things in very short time, things change very, very dramatically. Now, how dramatically they change, let me give you an example. Time to reach 100 million customers. Well, it took the telephone, about 75 years to reach 100 million customers around the world. It took the web, the internet, about 7 years to reach 100 million customers, users around the world. It took Facebook about 4 years to reach 100 million customers. Instagram, for those of you who use Instagram, 2 years. And here you go, Pokemon Go. For those of you who don't know what Pokemon Go, ask your children or your grandchildren. It's a computer game that you play on your cell phone. It took about 1 month to use 100 million users around the world. So this is how fast things change today. From 75 years to reach 100 million customers for the telephone, to 1 month for the Pokemon Go. And this film or this video actually, I think, demonstrates very nicely how fast things change. If this was your working desk, starting in the 1990s, look what happened to your desk today. Let me run the video again. So as you can see, things disappear and they are more and more integrated into your computers, whether it's your calendar, your news. So we don't hold newspapers anymore in our hands. We open our computers, our calendar is in a computer, our navigation is on the computer. We don't use maps anymore. I remember using to hold maps when I was driving in Europe, trying to navigate. Now, it's the phone or a device. So everything now is digitized. So this is how intense the revolution is and what we're experiencing. And then another number, just to give you a sense of how fast and how intense the revolution is that in 1990, about 1 million things in the world were connected. When I say things, I mean computers and technology, your house, your kitchen, your stove, your refrigerator. So 1 million things were connected. In 2020, already 50 billion things that we're using were connected, which means that they are connected to the internet, they're connected to each other. And the key word to remember is IoT, Internet of Things. And it means that things are connected and there is a lot of data being collected and being generated. Everything that we're using now is generating data, and data is then being stored. And then what do you do with the data? You use artificial intelligence. You probably heard this or read about this. It's about computers making use of the data that we are collecting from all the devices around us to reason, to come up with conclusions. Some of those conclusions are good for us. For example, on what the impact of the vaccines on our health is. There's a lot of AI work being done now in Israel about the impact of the vaccines. I don't know if you know, but Israel now, we're in the middle of our 3rd booster shot. So there's a big questions what the impacts are. Collecting a lot of data from people, using artificial intelligence technology to reason and to get conclusions from this big experiment. And when we say AI, we're trying actually with computers to copy the ability of our brain into a computer that can take the data and then come up with conclusions. Some of those conclusions are we won't even think about them because the data is there, but it's hidden. But the computer is able to figure this out. And as David Michelle said, there is nothing artificial about machine intelligence. It's there, and it's real, and it's very, very intensive. I mentioned data. I mentioned the word data a lot during the last few slides. Well, data is the new oil because people pay a lot of money. Companies are willing to pay a lot to get data about yourself, about your activities, about your preferences, about everything. So data today is the new oil, and if it's the new oil, then it must be very expensive, so you need to protect it. And there are a lot of regulations now around the world on how to protect the data, and Europe is one of the leaders in this area. Now, if data is collected, then it must be also collected about you. So who is afraid about your privacy? You know, people can hack or can take your identity, your electronic identity, and or the data that you store in your computer and use it against you, or you know, use it in non-ethical ways. And this led to a lot of business in how to protect data and protect people. Now, we also provide some of the data willingly because we are using smart computers, we're using smartphones, and we're connected to TikTok, to YouTube, to Instagram, to Twitter, to Google. All these applications on the web, they're there. And by the way, please note that they are free. You don't pay for you to use them if you're a simple user. But somehow they have to make money. These big companies have to make money somehow. So what they do, they collect data on you, because if you don't pay for your data, or if you don't pay for your product, you must be the product. So keep in mind this. This is something to bear in mind. So and this obviously opens a lot of questions about ethics. You know, what can we do with the data? Is it ethical to collect data? And this is part of this big revolution that we are experiencing now. Now, if you're confused, that's okay. We're all very confused about what is happening around us nowadays, even scientists. The fact that everything is so handy is there, and there's so much information on that you can use is something that is new to all of us. Some say that this is the most transformational times of human history, and I think it is, and even more. The impact is going to be profound. If there is a fourth industrial revolution, what will be the fifth? The fifth will be something which is mass customization and cyber-physical cognitive system. When I say cognitive, it means that it's going to become part of our body. Sensors that are implanted into human body, all kind of lenses and technology that are becoming part of you. You are becoming part of the network. We are part of this digital revolution. So data is going to be physically connected from us. The fact that I'm wearing a smartwatch, this smartwatch is monitoring, you know, my heart and my AKG or whatever, and there you go. The data that the smartwatch is collected is then being sent through my iPhone to a web application, and who knows, someone can make use of it to design devices, you know, for good and for worse. And many things that this revolution is green because it's digital. There is no grease, no oil, nothing moves there. But in fact, it's not that green, because if you go online and look and type CO2e in Google, you will notice that for every email that you're sending, you are creating 4 grams of CO2e, which is a unit of measuring how much pollution we are creating. And it's very simple, because when you send an email, you're using electricity. Electricity is now produced by fossil fuel, gas, you know, sometimes it's green energy, but most of the energy that we're using is not that green. So the digital revolution is not that green. If you're actually attaching an image to your email, you're wasting about 50 grams of CO2e. So bear in mind, these are ethical questions. You know, if people think or make you think that this revolution is green, where it's not that green. Well, about robotics. Robotics is part of this revolution, and why is because it's the most cyber physical system, and because the world is aging. You know, if in 1990, for a retired person, there were 6 people supporting him, you know, and financially, physically, today, the ratio is 2 to 1. And the structure of modern society is changing from a pyramid shape to a reverse pyramid, especially in the Far East, in China, in Japan, in Korea, where you see less and less people, young people, supporting that supports older people, because people live longer. And robots are there to assist and to replace people. how intensive this revolution in robotics. This is how this is how intensive. These are robots that are already in the market by Boston Dynamics. You can expect to see these kind of robots walking in the streets and doing some work around people on a daily basis. In the Far East, they're already there because they are already experiencing this impact of aging population. So these are not toys. These are robots that walk, run, jump, and doing things that I even cannot do. And Bill Gates wrote a very famous paper about 10 years ago that he predicts that the big revolution is going to be the robotic revolution. A robot in every home, it's going to be the next big revolution. Now, this actually raised a lot of ethical questions, because if robots are going to replace us, what are we going to do? Can we control how much robots do and how much we do? And this raises a lot of questions about the impact this technology is going to have on our life. And the prediction is that 2/3 of the companies would not survive the fourth industrial revolution because of technology. Robots are going to work side by side to people and take many people's job, which means that we will have to ask our governments to control this and to make new laws and restrictions and control this revolution. Otherwise, it's going to take over. Again, Bill Gates said that, maybe one day, because of the intensity, how intense this revolution is, robots will have to pay taxes. So if you are going to use robots in your business, you will have to pay income tax for these robots. Otherwise, you won't be able to support the society. We will not be able to have hospitals and schools operating because, it's all supported by our tax money. So when innovation and ethics collide, let's talk a little bit about this. Can we trust robotics? Well, Hollywood does a good job for us. Some robots in Hollywood are good robots, some robots are bad robots. So will you put your life in the hand of a robot or in an internet bot or something like this? Well, I think, again, Hollywood talks a lot about this, and talking to a UK audience, I have to, of course, refer to a movie out of the UK. Well, if you remember James Bond, the Skyfall movie, this is a very famous scene where James Bond is meeting the new M, the young generation.
Why? Because I'm not wearing a lab coat. Because you still have spots. Reflection is hardly relevant. Your competence is. Age is no guarantee of efficiency. And youth is no guarantee of innovation. I'll hazard I can do more damage on my laptop sitting in my pajamas before my first cup of Earl Grey than you can do in a year in the field. Oh, so why do you need me? Every now and then a trigger has to be pulled. Or not pulled. It's hard to know which in your pajamas.
I think this summarizes all. He can do more damage than James Bond, but there's a lot of ethical issues that, we have to take, when to pull the trigger. So this is the world we're experiencing. So can you program ethics into self-driving cars, which are robots, for example? What about liability of the sensor technology? The human ethical standards. Can you actually, the imperfection in our nature, can you program it into the car? Can the car determine whether the road is 100% clear? If you tell the car only if it's 98, then 79.9 is not 98. A computer is very binary. It's yes or no. Where we're very much in the gray area. Sometimes there are laws, but sometimes you don't obey the law because there are ethical concerns. And I'm saying not obeying, not in the bad sense of it. I'm saying you think. And a very famous dilemma is actually demonstrating it is called the trolley problem. There is a trolley a trolley that is running uncontrolled on a trail, and there are 5 people here tied to the rails, and the trolley, if it will continue to go, it will just go and kill these 5 people that are tied to the rails. and you are here, and you have the ability to pull this lever arm and then take the trolley, move it to the other rail, which looks to be open and clear, but when you look a little bit deeper, there is one person tied to the rails here. So the ethical question is, what would you do if you were the person standing here? Would you let the trolley run over 5 people, or you're going to, as it would do automatically, or you're going to interfere and drive the trolley to the right-hand side and just kill this person, and save the life of 5, and sacrifice a life of 1? What if you knew this person? What if this person is related to you, or you know him? These are ethical questions that it's hard to program and into a robotic device. Well, you drive on the roads, on a highway, if you see this truck and you see this small car, will you drive in the middle of the lane like a robot would do? Or would you, drive closer to this small car because you're afraid from the truck? If there is a cat running or jumping into your lane, would you go over the red or the yellow line just to save the life of the cat, although it's forbidden to cross the yellow line? These are things that you need to program into robotic devices. And I'll give you an example. This example is actually taking into consideration 3 gentlemen who actually had an impact on our life in the past. And one is Jeremy Bentham, that says that, you want to maximize the overall happiness and create it for everyone. And this is good for mankind. And Immanuel Kant, who believes in universal laws and that laws should always be obeyed. And of course, Isaac Asimov with his 3 laws of robotics. So here is the ethical dilemma that was introduced to almost 2,000 people around the world. You're sitting in a robotic car, automatic car, who drives very fast, where suddenly 2 pedestrians are crossing the road. Now the car is and it has 2 options. One is to stay, kill the 2 pedestrians. The other one is to swerve, save the 2 pedestrians, but kill the 1 passenger here. So these are an ethical question or dilemma that was introduced to people, to 2,000 people actually around the world. And of course, if you ask Bentham, he would say, yes, 2, if 2 is greater than 1, let's save the 2 and swerve and kill the 1 passenger inside the car. Now, if you ask Immanuel Kant, he would say, sorry, there is the law of robotics where robots should always protect the user or its owner. Therefore, the robotic car should save the person who uses it and run over. Now, this question was actually introduced to 2,000 people around the world. And the question was, what kind of car is more ethical? Okay, swerve or stay. When people were asked, what kind of car would you want to have on the road? Most people, actually all people say the one that would swerve, save the 2, sacrifice the 1. When the same people were asked, what kind of car would you buy? The same people said, the one that stay on the road, save me, and sacrifice the 2. And then they said they were asked, what if there were not 2 pedestrians, 3, 4, 5? Well, the answer was people started to change their mind only when the number reached 10. So people were willing to sacrifice 10 pedestrians just to save their own life as passenger of a robotic car. So these are dilemmas going to be introduced into car industries that we are here in Technion as computer scientists, roboticists, are always constantly dealing with, because they can actually take people's life actively. What about medicine? Well, in medicine, we have a very big contribution around the world, and there's also ethical questions here. This is some of my work starting in 1998, developing a robot for spine surgery. This robot is operating now worldwide, saving people's life, putting screws, pedicular screws in people's spine when there is a need for spinal fixation. The system was developed here. Some of the screws that are then introduced into the spine, into the vertebrae, actually penetrate the spinal cord that you see here in the center, in the red. 10% actually penetrate the spinal cord, and 5% leave a permanent damage to the patients. In a surgery, the minimal amount of screws that are inserted is 6. So the chances are that you're going to walk out of surgery with some kind of a damage. The robot does it automatically, very accurately, with 100% success. I'm talking about hundreds of thousands of screws worldwide, and it's making a huge impact on people's life, and on doctors. Everything is designed on the computer before the surgery, and then during surgery, the robot does the surgery automatically. As I said, very, very, very successful. I then moved to, after developing this technology, I moved to Carnegie Mellon. Tony mentioned it. And over there, after 9/11, I was asked to develop robotic devices that would go into collapsed buildings to allocate survivors after either disasters, natural disasters, or terror attacks. So we started developing these flexible robots, and some of them look like snakes, as you can see here, that can ease themselves into buildings to allocate survivors and to tell search and rescue people whether it's safe to go into the building or not. They carry a lot of sensors and they collect a lot of data from the site, and as you can see here, the robots. Now, these were used, and since I'm still in the medical robotics, I was introduced by a friend with another problem, is to try and replace the tools that are used today during surgery with something which is more flexible, because the tools that the doctors are using today are very rigid and straight line and straight. American doctors calling it operating with chopsticks, which means that if this is where you enter the body, if you have a clear sight to the point of interest, there's no problem. But if there is something blocking your way, you cannot go around it unless you were using something like a snake. So after a few years of development and a lot of investment, you could see here, this is the product. It's called Flex by Robotics. It's a snake robot that drives into the person's body and performs surgery in a distance location without even performing any surgery. The surgery is not visual outside, so no need to do any. You don't need to cut the person. You're using natural orifices in our body, transoral, rectal, vaginal, and getting deep into the body in a non-linear trajectory and perform surgery, as you can see here. And this is the technology that is working now worldwide. It's FDA approved and CE approved, and other things that came out of the Technion. One last thing I want to show you is this project, which is helping also a robotic technology that helps children around the world, that is developed in my lab. Is we are developing prosthetic hands to children who lost their hands or were born without hands, children that cannot afford an expensive technology that is out there in the market. The technology of their hands are printed on 3D printers. They have mechatronic devices there, the robotics, and the project is run by 2 of my PhD students, and more than 100 students around the Technion are involved in developing this technology. The alternatives today are the simple hook hand that you can buy, or very expensive robotic arms that are available on the market. And when I say expensive, the cost of the smart devices that are available today in the market are tens of thousands of dollars. Children cannot afford it. Most people cannot afford it, especially not a child that grows out of the robotic hand very fast. So this is where we develop these robots. We did a lot of study about how people use their hands, as you can see here, with animation and sensors measuring all that. And then we developed all the pipeline from measurements to a robotic prosthetic hand. Now here's the punchline. It's all free. It's a philanthropic, I would say, a project that we're doing free. We give those hands free all over the world to everyone who wants it. And all our designs are free on the web. So people can log in, download everything and do it in India, in the UK, in Brazil, wherever they are. And a lot of students are involved in this project. The cost of a hand that you see there, that you saw in the previous picture, is about $100 maximum. The most sophisticated one, $100. The one which are less sophisticated, $50, $40. Everything is printed. Here are some examples. This is a hand that was given to a child in the United Kingdom. You can see him here using the hand immediately. By the way, you can choose the color. You can choose the logo. This child loved Iron Man, so he wanted to have the Iron Man logo on that printed on the hand. Another hand that was given in Brazil, a hand that was given in the United States. By the way, one of the first hands we gave in Israel was for a Syrian refugee, a child from Syria that got treatment in the northern part of Israel, in the city of Tzfat, and we were asked to give him a hand. And even to Israelis, and you can see here Ben Spitzer is a soldier that lost his hands in one of the incidents in Gaza Strip, and he's using our hands already, our robotic hands, and he's helping us a lot in developing the technology. As I said, this is all free to use around the world, and here is a quick movie to demonstrate the technology, and I'll fast forward it. You can see, again, a girl wants it to be in pink, so you can print it in pink. All you need is a 3D printer, and we do it very custom-made almost. From a handicapped child, the child becomes a hero. Everything is designed on the computer and, as I said, available online. Some of the hands are more sophisticated. There are mechatronics, they have motors inside, they have computers inside, because of the amputation is higher and you need to have a robotic capability. Well, let me conclude now by talking about the ethics, and these are my concluding remarks. You see, we do a lot of robotics and a lot of technology around us, but we have to be very concerned about this because, you know, we already have around the world robots that produce robots. So what if one day robots are going to start building robots that are smarter? So what if this technology is going to go out of control, like you could see in some of Hollywood's movies? What if the next generation of robots are going to look like Sophia here, which is already a working robot in Japan? I think she got a citizenship I think it's in the United Arab Emirates. These robots that are more, they really resemble humans. They're called androids. Their face, their skin is almost like human. They're going to walk side by side next to us in the streets, and we're not going to be able to notice that they are humans. So if this revolution is happening now, you know, what about our future? You know, what's going to distinguish between man and machine? You know, we already have technology implanted in us. So what makes a human human and a machine machine? Well, the Pandora box is already open. The revolution is here. Technology is here. The demons are out. We cannot reverse the process. It's going to be very hard to do that. You know, technology is good in many ways, but we need to control. We need to be aware of the impact it's going to have on our life. Well, it's going to change the evolution. Yes, it's going to change the evolution of mankind, of humankind, the same way that the stone changed, you know, the evolution of mankind in the Stone Age, or the metal in the Bronze Age. You know, whoever mastered the stone or the metal were the entrepreneurs of their time, and they survived. So technology is part of our life, part of our evolution. you saw a lot of robots doing very nice things there, but one thing robots are still inferior to humankind, and is the dexterity. If you read Noah Harari's books, one of the things that distinguish us from other animals is dexterity, fingers. So I don't know robots still that exist around the world that can do better than this, would do better than this lady in this competition. So the dexterity is still a great challenge for roboticists. However, let me warn you about self-awareness. Self-awareness is something that we have. You know, the doctor that performs a surgery on a patient is human, and he knows that he's operating on someone's father's, on someone's grandfather, where robots, they just operate on something because they're told to do that. So the moment you're going to see robots taking selfies, meaning that they are developing self-awareness, you have to be alert. Stephen Hawking says that AI and this revolution is going to be the worst thing that ever happened to humanity, but it's also a good thing. You know, we're using this technology every day. Here at the Technion, you know, we believe that if you want to predict the future, you have to create it. And this is what we're trying to do. We're trying to create robotic technology to help children, to help doctors, to help people around the world. That's our way of trying to predict the future with ethical awareness. Thank you for your time. And if you have any question, I'll be happy to answer.
So let's take the first question from Rita.
I just wanted to ask, obviously it's amazing what the Technion does. I'm always impressed. I went on to your last talk and I did one with a camera in the body. I've never forgotten that one. And Peter's cousin had it, so I always remember you. Now, my question to you is, it's wonderful, all the data we do, but do we do anything about scammers? Obviously, the more data, the more scammers. Is there anything we do on that side?
What do you mean? Can you, I don't think I understood the question. When you say scanners.
Scammers, people scam you online because we're accumulating so much data.
An MRI, for example, Alon.
What, Tony?
Like an MRI, for example.
Oh, yeah, scanners. Yes, there is a lot of technology developed there. Actually, I'm involved now in a project with that came out of the Technion and now is being implemented in the Hospital for Special Surgery in New York, which is the biggest facility for orthopedic surgery in America, where we develop technology to analyze scoliosis in children, spinal deformities in children without x-rays, just with a camera, which is going to revolutionize how scans, you know, because a child that suffered from scoliosis or lordosis have to take constant x-rays to evaluate the curvature of the spine and the dynamic of this situation and the effectiveness of the treatment. And we're developing now a technology based on cameras that have the ability for 3D, to take 3D pictures, cameras that are already integrated in cell phones, so the doctors don't have to send the children to scanners like CT or MRIs. They will take a photo with a smart camera, and he will get the same results that he would have gotten had he been using a CT or an X-ray. So there's a lot of, this is one example, and there's a lot of activity there, and now developing new modalities to acquiring medical data without using, for example, radiation. Okay,
Alon, let's go on to John Fixler, who's sitting there with a question. John, you're muted. Can you unmute? Then we'll come on to Mr. Hammerman.
Okay. Thank you very much for the most fascinating insight into robotics and what you do. What I'd like to find out is that these robots come in different sizes, small, large, carrying out the most fantastic feasts, and nothing seems to be impossible. How are they powered? And if they've got any batteries or whatever it is, And how do you ensure that they can carry out the task they have been allocated to them on one charge of a power?
Excellent question. It's an excellent question. One of the main challenges in what we call autonomous system, when I say autonomous, meaning that they are unplugged, not plugged to the wall, so they don't take power from the wall, they rely on energy power. One of the most difficult challenges are to design batteries that are going to allow this technology to function more than a couple of hours. We all to our cell phones sometimes midday if we are heavy users. Now, Technion has in several major projects around what we call energy cells. So batteries are now referred to as energy cells. So it's a device that generates energy. So we have a very famous centers here. The next generation of batteries, by the way, which are going to be called energy cells. Now, another approach is, for example, for devices that are implanted in our body to be energized by the power that our body is creating. It's called energy harvesting, to harvest the energy from the human body. I'm sure that some of you were aware of mechanical watches, which are automatically charge themselves by the fact that when we walk, we wave our hands. So you are harvesting already energy from your motion to energize your watch. Now, the same technology now is being applied to harvest energy from the human body to energize implantable or those robotic limbs, for example, that we give to children. The energy will be harvested from the child itself. Just a side note, a robot that you saw walking, running there, you cannot harvest the energy from the robot, because then you are actually not obeying the law of thermodynamics, which means that you cannot generate energy from the same machine. In other words, you cannot have a automobile or a machine that runs forever. You need to have some kind of energy source to energize it. So harvesting energy from the motion, from the sun, from the environment, from wind, from the human body, and the next generation, as I said, of batteries are named energy cells. This is an excellent question. This is a great challenge.
I don't think that.
John, we've got to move on. We've got a lot of people on questions, please. Mr. Hammond has been waving his hand very patiently.
Thank you very much. Yeah, very interesting presentation. You mentioned that you opened up in China in 2015, and I don't know if you saw it or your colleagues did, but there was a very interesting program last night on BBC Two about the way that China uses its knowledge and uses other people's knowledge. Now, do you see China as a cooperator, a friend, or is it a competitor? And how do you stop people getting into your systems and using the knowledge you've got and taking it from you?
Again, a very good question. We see China as both. And with the university that we have now in China, what we do is we teach there, and we make sure that the topics that we teach there are those that they are carefully chosen. So they are related to environmental impact, civil engineering, with environmental impact. And unless we don't develop technology over there on campus, they do it themselves. We are more responsible for the academic programs, for teaching the elementary, I would say, courses and elementary programs like in mechanical engineering or civil engineering, etc. Now China is there, and you cannot ignore it. I think that the fact that we have a campus there and we do it in a very controlled way, it actually opens up opportunities for everyone. Again, bearing in mind that there is also risk involved, and we are aware of that.
Thank you.
It was a great question. Look, we are starting to run out of time, and we could go on all afternoon with many more questions. We are going to have to finish shortly. And I think it would be an appropriate time at this point just to thank Alon for a very incisive and very interesting talk. And this is what goes on at the Technion. Scientists at the Technion are dreaming and doing of things, which makes the Technion such an exciting place to be. Very much like to thank Bushy Stage for hosting and organising today's event, and everything runs so smoothly. Now, Alon's research and many of the projects at the Technion wouldn't be possible without all of our support. We would ask you to think about, consider leaving a gift in your will at some stage. It's so important that we've made we've made a very short film about the importance of leaving a legacy in our wills as some form of an appreciation of the work that Technion and Technion Science is doing. So thank you everybody for joining, and let's play our final short film. Thank you.
I'm Tony Bernstein, and I have been associated with Technion UK for over 20 years. The Technion opened in Haifa in 1924. It's Israel's oldest university, and its mission has been to train the engineers and scientists who would build the future state. Now, with 4 Nobel Prize winners, it's one of the world's foremost science and technology institutions, and it's changing the lives of people across the globe. Every one of us continues to benefit from the Technion's many scientific breakthroughs. Over the years, I've been privileged to meet the researchers and visit the labs, whose groundbreaking work is so fundamentally important to all of us. Technion graduates developed the Iron Dome missile system, which has been so critical in defending the state of Israel, and a camera in a pill, which replaces the need for a more invasive endoscopy, is now used in many UK hospitals. It was Technion's Professor Hossein Hayek who developed an artificial nose that can detect different types of cancer. And Professor Alon Wolf, who developed a snake-like robot for use in search and rescue operations and micro-robots for use in surgery.
And responding to COVID, Technion scientists have developed a host of game-changing products and equipment to protect people on COVID wards, all helping turn the tide on the global pandemic. These are just some of the critical breakthroughs made possible through the generosity of our donors. I'm Daniel Pelt. I was chairman of Technion UK for over 12 years. Families from the UK have provided scholarships for research students, funding for research, sponsoring state-of-the-art laboratories and equipment, building student dormitories, and much needed facilities on the Technion campus.
The work of the Technion is so important to me that I have left a legacy in my will into its research into cancer detection techniques. I know that my money will be put towards educating the brightest minds whose research will open up new frontiers in science and innovation that will directly benefit my children and my grandchildren.
The challenges of every generation will be immense, but the scientists at the Technion will always be there to help. A gift in your will can ensure that new scientific discoveries will pave the way for a safer, healthier world for us all. I invite you to join the Technion family with the knowledge that your legacy will create an everlasting memory for you, your family, and for future generations.
Thank you very much, everybody.
Tony, thank you for hosting this afternoon. Just in terms of people are interested in leaving a legacy, how do they go about that?
contact Technion UK. Alan, the Chief Executive, is watching this at the moment. If they come through to you, please direct them through to me or to Alan. We'll be delighted.
Okay.
We're on the internet, our phone number's there, our website address is there, and we very much welcome a conversation with anybody that thinks this is such an important thing to do. And it's such an easy thing to do as well.
Thank you, Tony. Thank you to Alon for that presentation this afternoon. It's been fascinating and opens up areas that we have not even contemplated, but also presents some challenges in terms of how individuals will deal with it, handle it, and benefit at the same time. So many questions, so many answers still to be fulfilled. And Alan, thank you very much for helping me to organise this afternoon. It's been fascinating as always, and thank you to all those who have joined us. We've obviously got a lot of Sage people on, but we've also got a lot of people who have joined us. I think probably from Stanmore community, but other people who are interested in the work that Technion does. Alan,
well, Stuart, and also from Chigwell.
Let's not forget Chigwell. Alan, is there anything you would like to add before we go? No? Okay, Alan is just relaxing there. So Tony, thanks again for hosting this afternoon. Thank you all for joining us.